Now that we've got the entire IF line completed, we know now that if we send to this point here an IF modulated signal, or rather a modulated signal at the IF frequency, it is going to go through the audio, or rather the RF chain, in its optimum condition, and that's what we need. So what we need now is to go to the front end and to the oscillator and do the RF alignment. And the RF alignment is simply a matter of aligning the oscillator frequency and the front end RF frequency that we tune to coincide with what we're seeing or expecting on the dial of the radio. So what we have is we have two sections here that are now of interest. This section is the front end. What happens here is we select using these switches over here, there. We basically select what band we want, so short wave, medium wave, or long wave, and what that does is it switches in the respective tank circuits that we're going to use for that particular band. We know this top one here, for example, this one over here is the short wave, and then we have a medium wave, and then we have long wave, but we're not too concerned now as to what exactly switches in what, because ultimately what happens is that this tank circuit does a pre-selection really of the frequencies, which then go to this point over here, which is connected to one half of the variable condenser. And when we tune this condenser, it tunes to the frequency that we want to listen to and sends that up into the mixer circuit. Now, this is the last part of the entire tank circuit that this section here sets up for us. So this is the common denominator, this condenser, of these pre-selections that we do, and this condenser, it's one condenser that works for all three bands, tunes that band to that particular frequency that we're looking for. This second stage on the right is the oscillator. Now what that does is it tunes also using the other half of that tuning condenser. It tunes the oscillator frequency to match the frequency that we've chosen here on the front end. So what you really have is a front end that produces or tunes to a frequency F, depending on which band you've selected. Okay, let's call it 1 megahertz, for example, if you're on the medium wave band. And that particular frequency then is matched by the selection, the tuning on the oscillator, which will tune not to 1 megahertz, but to 1.46 megahertz, because it has added to it the IF frequency. So you're tuning simultaneously two tank circuits, and then you're going to take these two frequencies and mix them with in the mixer tube, which is the ECH81 in this case, and that's going to produce that IF frequency of 460 kilohertz modulated with the audio that you are trying to listen to. Now the important thing when you want to do the front end alignment is you want to make sure that, first of all, that the frequencies that you are tuning to correspond to what you see on the dial of the radio receiver. So when you tune the front end and the oscillator, you do that by placing the dial on a known part of the dial plate on the display, and then you adjust your oscillator. You don't adjust that one first, you adjust your oscillator to bring that signal into the position of the dial that you've selected. So you adjust it slightly. Usually it's not too far off, sometimes it's not off at all, but you adjust it so that your particular frequency you're looking at is exactly where you expect it to be. And then what you do, because you've adjusted this tank circuit, you then adjust that tank circuit so that the strength of the signal that you're hearing at that point is optimized, is as high as strong as possible. So you filtered the front end to match the frequency you're tuning to by moving around the oscillator frequency. Okay? So you basically have these two frequencies that you're tuning in conjunction with what you're seeing on the front dial of the radio. And this signal, the front end, obviously comes from the antenna, which is off to the left there. And that's basically what you're doing when you're adjusting the front end of the radio. Now, we're going to look in more detail how that's done, and I'll show you how these are aligned. But I just wanted to give a quick overview as to what exactly it is you're doing and what part of the circuits you are adjusting. What you're actually going to adjust in the case of the RF or the antenna circuit is you're going to adjust these variable coils on the input circuit that have adjustable lugs in them. You're going to adjust that one, that one, that one, that one, and so forth. In some cases you will have capacitors as well. And in the case of the oscillator circuit, you do exactly the same thing. You've got a variable coil there, another one there, another one there. This is a variable capacitor that's also adjusted. So in some cases you're adjusting the capacitor, in some cases you're adjusting the inductor. And what we do is we set this up to a high frequency and a low frequency on the same band, and you adjust them so you're not only getting a correlation on one point of the dial, but you're also squeezing it or spreading it out so that it matches the frequencies on the other end of the dial as well. Now, as I mentioned before, I don't have the actual service instructions and alignment instructions for this particular radio, the 4198. What I do have is for this trio, 5016, 5017, 5019, and what I've found is that in terms of layout, they are fairly similar. They're not exact, but they're fairly similar. So with that in mind, and being careful not to assume that they're completely the same, this is the set of instructions that I'm going to use. Now, I've used this successfully, or fairly successfully, to do the IF alignment. I've found that the coils actually match fairly well, especially on the AM at least. This particular radio, this 5016, has an extra IF transformer, but that's fine. The first two matched quite well. Now, when it comes to doing the actual RF alignment, they give us instructions here, and what they're basically saying is you set to medium wave, you set it to 560 kilohertz, and you adjust 1 to maximum. Now, what does that mean? You've got to know what 1 and 2 are. The rest is not really that important, but you've got to know what coils these are, 1 and 2. Then you move it to, you adjust for 1450. In other words, you're putting a signal into your radio through the antenna at 1450 kilohertz, and you adjust 3 for maximum output on the speaker, and you adjust 4 for maximum output on the speaker. Now that's all very well, but if you don't know exactly which these are, you're wasting your time. So what do we know, what don't we know? We can set 560 kilohertz with a modulated 600 hertz signal coming out of our signal generator into the antenna. That's not a problem. We can set that frequency. That's not a problem. We can then choose long wave, select long wave on the radio, and we can do the same, inject a signal at 160 kilohertz carrier with the modulation. Not a problem. Long wave has one adjustment only at 8 megahertz. Not a problem. Okay? So what we need to know is, what are these guys? Where are these guys? You remember this drawing we had? This was used for the IF alignment. Now, these two transformers matched perfectly when I did the alignment on this radio. This last transformer, in our one, only has the FM coils. So it's only an FM IF transformer, it doesn't have the third AM stage. What we also have is this. Now, we have to be very careful. This is the FM, that's the AM. So if we look at the AM, what they're telling us, if we look at the switching block from the back, from the underside, this is where that 1, 2, 3, 4, whatever adjusts to. And that's basically it. We've got 1, 2 isn't here, but 2, they tell us, is actually the variable part of the ferrite antenna. So that's quite cool. We know how to get there. Then we've got 3 and 4. 3, 4 are 2 capacitors. These are 2 trimmer capacitors. 5, 6, 7, and 8. So that seems to be fairly intuitive, provided these match the ones we have. Now, how are we going to do this? Well, we're going to set it up assuming this is correct, and then we're going to make very small adjustments where we're supposed to, and we listen out to see whether that makes a difference. If that doesn't make a difference, then we know we might have a problem. We may have to find the corresponding coils and capacitors by looking at the circuit all over again. But I think that might not be necessary. We'll just play it by ear and see. So the next stage is set up the radio and set up all the equipment and get ready for this part of the alignment. We've got our signal generator ready to go to do the RF alignment. So what they tell you to do, and I'll show you the instructions in a second, is to set up a signal generator for a 560 kilohertz carrier, which we've got here. I've put the amplitude to the minimum possible. Now I add modulation, which is AM modulation, 30% depth, and that's on. Now that's coming out here. And what I need to do now is I need to feed it through a dummy antenna. Now the dummy antenna, according to instructions, is simply a 220 picofarad capacitor in series with a 220, I believe it is, ohm resistor. That's going to go into the antenna socket. Okay? So I'm going to put that into the AM antenna, the external antenna socket. I'm going to connect the ground of the signal just to a convenient chassis ground point. Now let's see what it is we want to do. What we're going to do is we're going to do the AM alignment, RF alignment, and we're going to start here on medium wave. Now what they tell you to do is set your frequency to 560 kilohertz, adjust the oscillator to maximum and the antenna circuit to maximum. Now what this means is you have to set the dial to 560 kilohertz and adjust 1 and 2 so that the maximum signal, that audio signal you're going to hear, is maximum at the 560 kilohertz point on the dial. Now that's the lower end. You then move, you change the frequency to 1450 kilohertz, and you adjust 3 and 4 to give you a maximum when your pointer is at 1450. Now I want to show you what these adjustments look like. This is them over here, and according to our instructions for the 5016, it tells us that we have 1 in the middle and 2 isn't here at all. Now it's 1 and 2 for maximum. So what 2 is actually that variable part, the adjustable part on the ferrite core. So we can slide that up and down, and that's the adjustment we make. Now I think that is the same 1 that we expect to find on here, but we have to be careful that we don't adjust something incorrectly, because I'm not sure, as this is not the actual instruction for this particular radio. So if we are right, then the one we need to adjust is that guy over there. That's 1. If we are wrong, we're going to mess something else up. So what I'm going to do is I'm going to switch on the signal from the signal generator. I've set the radio to medium wave. I've got the speaker connected, and I've got an AC voltmeter across the speaker. So we are going to see how close it is or how far it is from where it's supposed to be. Now the way this works is, if you look at where the pointer is, it's now at 550, okay? That is over there. There's 600. And just here, there's a little line. And that little line is actually there for a purpose. It's to tell you that's the 560 point. Now, I'm going to set everything up. I'm going to switch on the signal generator. Let's put the volume up. We're at 560. I think I can just hear it. So it must be close. There we go. That's where it's peaking. So now what I need to do is to peak it at that point, which is 560. So let me go down. What I'm going to do first is make sure that the one that I think is number 1 is indeed number 1. So I'll put it on maximum and tweak that particular coil and see if we get any adjustment at all. So it's on maximum. That's the one I believe is number 1. Yes. You see? That does seem to be the one for the oscillator. So that's why I'm getting a maximum. Now if I tweak it to 560, leave it on 560, and now I'm going to tweak it so that I max it at 560. Let me lower the volume slightly. There it is. That's peaked at exactly 560. Now it also tells me to do number 2, which is this guy over here. So what I'm going to do is I'm going to move it with this little wooden stick. I'll keep an eye on the meter from this side and see where we get the peak. We shouldn't touch that. It's a bit difficult, but I'll do it from the top. It's going up, up. It's going down. Try the other way. You see, you can't do it with your hand because it affects it. It's on the way down. If I do that, adjust slightly and then move my hand away, it's going up slightly. That's the peak. So I've done 1 and 2. Now I need to do the same thing for 1450 kilohertz. Same modulated signal, that's going in there. If you notice there on 1450, there's 1.4, there's 1.5, there's 1.6, there's another little dash over there to show us where 1450 is. Now I'm going to put up the volume, and I don't have anything there. There it is. It's very close. I can adjust it just slightly. I'll leave it on there and we'll peak it. What it tells us to peak here is 3 and 4 for maximum. And 3 and 4 are actually these two little variable capacitors. So I'll keep an eye on the meter. There we go. That's a peak of the oscillator, and now we'll do the antenna one, which is this one here. That's a peak. Volume down. So there we have it. We've actually done the medium wave RF alignment. What we need to do is check the 560 again to make sure it hasn't drifted when we moved the upper frequency one. So we've got the generator at 560 and we're going up. There it is. I'm looking at the meter. That's my peak on the meter, and where is it on here? Near as damn it, it's slap on. So that is done. The medium wave RF alignment is done. Let's do a test on 1 megahertz just for fun. So I've got the generator sending a signal of 1 megahertz, and I'm moving up the dial to 1 megahertz, just about. There's the maximum, and that's it, near as damn it, it's there. So this dial is not only aligned, it's also linear. It also corresponds properly to the middle of the dial as well. So our medium wave RF alignment seems to be complete. Now they tell us to do the long wave. And the long wave is just on the 160 kilohertz position. Select long wave, send a 160 kilohertz signal, modulate it, set the dial to 160, and adjust 5 and 6 for maximum. Now 5 and 6, according to this, is the first one on the left there and the second one there. So it's that one there and that one there. So we select long wave, we go to the dial, and again we have a there's 175, that's 150, that's 160 on that little line over there. That's where we should hear it. Well, it's there. Slightly out. It's actually peaking over here. More like over there. So I'll put that on 160. Now we're ready for shortwave. And shortwave tells us to go to 8 megahertz. Now 8 megahertz where is that? 8 megahertz. There it is. So we'll set the dial to that. Okay, we'll set the signal generator to 8 megahertz. Try and do this one-handed. And it should be volume up. Oh. Damn, that's close. Hell, that's should be the maximum's over there. It's just off. Let's try peak it anyway. That's on 8 megahertz. And according to this, we have to peak 7 and 8 to maximum. According to this, 7 and 8 are the two outside ones. So, I could just hear it. Whoa! Volume down. Volume down. Oh boy, okay. Let's try and peak it. Still too high. Volume down. There we go, we peaked it and we passed it. That seems to be our peak. Now let's do the antenna coil. There's our peak. Brilliant. So now we're done with these dreaded coils. They're always a bit finicky. They have they have wax in them, and they shouldn't have been very far off, but with age and component changes and so on, it does make a difference. Now this guy over here, this one here that we haven't touched, it's noted as number 7, Roman numeral 7 on there. What that is an IF trap. Now what you're supposed to do is you're supposed to put it at 460 kilohertz into the antenna. That's the IF frequency. So let's try that. 460 kilohertz. Put it on medium wave. And that should trap, that should not pass any signal at 460 kilohertz. The reason you want that is you don't want outside IF frequency coming in and messing up the one that you're trying to create inside. So that should cut out 460 kilohertz. And I'm not going to mess with that because I don't hear any tone at all. You hear noise, a lot of noise, but no tone. So I think that one's set well. The wax on this was not at all messed with. This wax is very fresh. There are no other components really around that. That's straight from the antenna that goes in through that or across that to stop the 460 kilohertz IF frequency. So that guy's staying exactly as it is. And what we have now is we have our radio, RF aligned. All the AM bands have been IF frequency aligned, and now the RF alignment has been done. And as we saw from that example in the medium wave, the correspondence between the actual frequency that we're listening to and the one we see on the dial is actually pretty good. Right, so that's it for the AM, and that's it for now. I'm going to actually do a bit of study on the FM circuits before I post or do a video on the alignment of that. See you soon. And if you like this, subscribe. Bye for now.